Right, let's rock and roll. This is number 5. It goes in. Nitric acid is manufactured from ammonia in a process that involves several stages. In the first stage, ammonia is converted to nitrogen monoxide, and following equilibrium is established. The catalyst for this equilibrium reaction is platinum rhodium alloy in the form of a gauze. See, while I'm reading this, catalyst gauze is heated initially, but then remains hot during the reaction. So as I'm reading this, I pick up a couple of things. First, it's an equilibrium. Secondly, they mention the catalyst in detail. 2 things. They mention it's a gauze, and they mention it's initially heated. And in my head, while I'm reading, I'm thinking, well, those 2 things are likely to come up. Let's have a look. 5A1, in terms of redox state, what happens to the ammonia in the forward reaction? Well, there's a number of different ways of looking at it. It's entirely up to you. Here's the ammonia, and it ends up as NO, an oxide. Well, it's oxidized. That's one way of looking at it. If you add an oxygen, it's oxidized. The other way to look at it, and if we look at the old term, oil rig, oxidation is loss. Now I can remember it 2 ways. Oxidation is loss of electrons, or oxidation is loss of hydrogen. Oxidization is the addition of oxygen, the loss of hydrogen, or the loss of electrons. If we look at it here, we've got hydrogens, and here we haven't. So it's oxidation. Alright. Suggest a reason why the catalyst must be hot. Well, that's to ensure that there's sufficient energy sufficient energy to overcome, and I'm going to be technical, EA, and that's the activation energy. Well, suggest a reason why the catalyst remains hot during the reaction. We have to think, well, if it remains hot and it's a catalyst, we know the catalyst isn't changing, or else would it be a catalyst? Well, why does it remain hot? Something must be heating it up. The something must be the reaction itself. So the answer to this is, why is an exothermic reaction? And finally, let's scroll down a bit. Let's see if we can see. This is a 2-mark question. State how a catalyst increases the rate of a reaction. It's a 2-marker. Well, first, it provides an alternative route. That's one way you could put it. You could also state that it's the reactants adsorb onto the surface, and you've got to be careful about that because the word is adsorb, not absorb. So adsorb onto the surface. Well, let's go. It provides an alternative route. Alternative route. Okie dokie. And because it provides an alternative route, because adsorption occurs, it lowers, and the effect of it is to lowers the activation energy. And that was quite an interesting question because we've got what, 2, 3, 4, 5 marks for an equilibrium reaction that was given to us, and nothing to do with the equilibrium itself. Okie dokie.